For this group of students, drilling, soldering, and wiring is all part of learning science, a hands-on lesson in the making of robotics.
I started teaching them electronics, circuitry, Ohm's law, resistance, power, electrical continuity testing, all that sort of real life stuff. So then what I wanted to do is I wanted to incorporate and nest as many physics concepts as possible into one project. Then I felt like it would be a truly authentic experience.
The project is called Survive the Surf, and it's part of the 9th grade physics class at HTH High in Chula Vista. Students in teams of 4 design, construct, and create customized underwater remotely operated vehicles.
So they went from having no instructions or directions on how to build a robot to creating their own blueprints, creating their own drawings, because it was their idea. They knew how it should be built.
So we first started off by getting into groups and brainstorming what we wanted our robot to do and what we wanted it to accomplish. Once we built the frame, we started working on the controller, which was a bunch of soldering, electronics, figuring out the current, the amps.
Teams had creative control throughout the engineering process.
It was really nice. We had a lot of freedom. You can see all the robots are different because all the groups had different designs. And we had a lot of freedom to design and build the way we wanted to, use the amount of parts we wanted to.
They each had their own mission. Did they want it to be super fast? Did they want it to be the ninja bot? Did they want it to be a slow, steady robot for great underwater picture taking and great underwater photography?
To help the design process, Alex Dole from Teledyne Robotics visited the class and brought in one of the many underwater robots the company manufactures. He talked to the students about the use of robots.
It really helped boost their enthusiasm and their connections because they realized, this is real world stuff.
The teams designed a variety of robots that had one common goal: surviving underwater. One of the highlights was testing their robots in the combat training tank on the Naval Amphibious Base.
I think testing it in the pool was really cool just because it was deeper and we can go down and up and test our motors.
I've always liked working with science. I think the physics part of this project was really cool, like finding out the buoyancy and doing the different tests, the motor tests and all that. That was really fun.
More testing was done on HTH High's campus in an inflatable pool.
I can't stop them from driving their robots in the pool. They're just very genuinely excited about robotics and engineering now, and so it's just changed my whole perspective as a teacher, that if you push them to new levels, they will jump with you and they'll follow you there.
Amidst the wires, cameras, and batteries, a social experiment was also taking place. The class was divided into boys and girls.
So I had the girls learning electronics and robotics all on their own, and the boys learning all the electronics, robotics on their own. And so I'd always was curious, do their grades do better? Do their designs do better? What does this look like compared to other years?
Because we were separated into genders, everyone stepped up, everyone did their work, and everyone shared their ideas. There's no intimidation at all.
The experiment proved to be successful. There was more participation in both groups.
We all did part of the solder, we all did the construction, we all had parts of the design. We listened to each other and we worked together.
So it blew my mind. I had not expected that at all. And the other thing that really shocked me was that the quality of the work for both the guys and the girls greatly increased.
During the 2-month process, the teams documented every aspect of their work on project websites that consisted of technical writing, daily progress, and photojournalism. Once the robots were complete, 6th graders from neighboring HTH Elementary were invited to a presentation to see the robots in action.
I want to find ways to integrate robots into physics through everything, because I realize it's really powerful.
To go forward, you push it like that.
A powerful and memorable experience for these engineers in the making.
Miss Quinny is she knows what she's talking about in physics, and she's actually really excited to teach. And I think that gets us excited for our new projects.
She gives us hope. She believes in us. She knows we can do our work with 100% effort, a bunch of hope. She knows we can do it.
She just teaches her subject in a way that it works. And also, she's just a fun person.
Just to see their genuine enthusiasm and excitement, and just to see their whole pride for their entire project, that's why I love teaching.